So our last section here is just sort of more for familiarization, because you'll see these kinds of names in other writings and such. And that has to do with the naming of organic compounds. And organic compounds are compounds that contain mostly just carbon, hydrogen, nitrogen, and oxygen for the most part. And there's whole fields of chemistry that are just called organic chemistry. And it's all based on sort of this carbon. And organic compounds, are your big, ugly behemoths. So like your biological molecules, your drugs, your carbohydrates, all your foods, all the complex sort of chemistry of life, if you will, are organic compounds. And once you start getting to really big compounds that have hundreds of atoms in there, the naming becomes really, really difficult. So as a very base level of understanding how we name these how we name organic compounds, I just want to talk very briefly about naming simple alkanes. And alkane, at this point, you don't necessarily need to know what it means, but it's just organic compounds with just simple single bonds. So here's the simplest organic compound, a carbon with 4 hydrogens bonded to it. And this is called methane. And the way it's sort of broken down into 2 pieces, the meth is a word that represents the number 1. And ane is a word that represents, it's an alkane. So it's an alkane with 1 carbon atom. That's what the name says. An alkane, so all single bonds connected to 1 carbon. If we have 2 carbons bonded together and everything else single bonded to hydrogens, there are 2 carbons there. And the name of this compound is actually called ethane, because the letters ETH means, there's 2 carbons. And the ANE means an alkane. If we have 3 carbons all connected to each other and everything else is bonded to a hydrogen, all nice single bonds, so that means, again, it's an alkane, so we know it's going to end in ANE, and all we need to know is what's the word that represents 3 carbon atoms, or the letters that represent 3 carbons. Those letters are the word prop. So anytime you see prop, that means, 3 carbon atoms. And of course, we can go on all day long and talk about, there's words that represent 4 and 5 and 6 and 7 and 8 and 9 and 10, 11 and 12. I think at 12 that pretty much ends. And you don't need, I'm just sort of giving you a familiarization so you are not completely confused if you see the word propane. You're like, what does that mean? So those are for simple alkanes where it's just carbons and hydrogens and all single bonds. In this case, here we have an oxygen and we actually have an OH sort of group bonded to the carbon. So this is a different class of compounds. These are all alcohols. If it's got an OH group, it's an alcohol. So the naming scheme is a function for alcohols has its own naming scheme. So you'll notice there's 1 carbon, it's all single bonds, and it has an OH group. And so this compound is called methanol. So the meth represents 1 carbon. The AN represents all single bonds, and the OL means it's an alcohol. So you should be able to, understanding this sort of very simple system, be able to figure out what the name of this compound is. I have 2 carbons, I have all single bonds, and there's my alcohol. So 2 carbons is eth, AN because it's all single bonds, OL, and sure enough, that's called ethanol. And then of course over here, by extension, we can have 2 different places we can put this alcohol. So notice over here there's only 1 place to put the alcohol because if we put the OH on the other carbon, it's still the same thing. But in this case, notice I have 2 different places I could put the OH group. I could put the OH group here on the end of the chain of 3 carbon atoms, or I could put it here in the middle. These are 2 completely different molecules. They have different chemical reactivity. If you have 2 molecules that have different chemical reactivity, then you have to give them different names. That's one way of remembering the sort of naming system. If, those 2 molecules are the same, then they're going to have the same name. If they're different molecules, then they have to have different names. So we can't call this molecule propanol, which is what you want to say because, look, 3 carbons, so there's prop, all single bonds AN, and then put an OL. So we can't call them propanol. We actually have to give them a different name and we have to add one small piece of information. That small piece of information that we add is the locations. And the naming scheme is we actually, in this case, we put a 1 in front of it to say it's on the first carbon in the chain of 3 carbons, all single bonds, there's the alcohol. And this compound down here is called 2-propanol. They're both propanol, but there's 1 propanol and 2 propanol because there's 2 different places of putting it. Now again, this is a very simplified explanation, and for those of you who go on and take organic chemistry, you will spend days talking about naming organic compounds. But this is, I just wanted to sort of show you the very systematic method for naming these compounds. It's actually quite straightforward, such that you can take a name, even for a large complex molecule, you can take the name and then sort of build the structure, the structural formula, which is ultimately what we want, dictates reactivity, based solely on the name. And just sort of to show you how silly it gets really, really quick, this is the molecule azithromycin, which is just a antibiotic. I was prescribed this as an antibiotic for, I don't know, some sickness that I had at some point. Notice down there, there's the molecular formula, C38H72N2O12. This piece of paper is actually that little information sheet that comes whenever you get drugs. They're required by law to put in this information that talks about all of the hazards of the particular compound. And in many of them, they'll actually give you the molecular structure. They'll show you the structural formula, they'll give you the formula, give you the molecular weight, and then they'll give you what the technical name is. Now, this is called azithromycin, which is a relatively simple word. And here is the actual legitimate, straightforward, following the rules strictly name for this compound. But this compound has a little over 100 different atoms in it, and so this is obviously a very complex atom. And of course, you look at that molecular formula and there's a gazillion, well, maybe not quite a gazillion, but there's a lot of different ways that this molecule can be configured. If I have this many atoms, there's lots of different ways I can sort of connect it to make various different shapes. And all of those will have different compounds, and all have different reactivity. So we have to be very clear as to which one are we talking about. Well, this is how we do it. There's our systematic name. And so obviously when you're getting to these big, huge, complex things, you have to add a bunch of stuff that we didn't talk about in the last slide, but there's a 2R, 3S, 4R, 5R, 8R, 10R, blah, 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 deoxy, 3C methyl, 3O methyl, la, 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 gets all the way down to one. It ends in the letters O-N-E, right? In theory, a good organic chemistry student should be able to read this and come up with this picture. Say, oh, okay, and just reading that word, that very long word, come up with this structure. Would that take a while? Yeah, probably. I don't even think that would be worth as a final exam question. But again, I'm just trying to show you, this is the systematic naming scheme that organic chemistry follows. It's very descriptive and says this is exactly where all the atoms are and how they're connected.